All right, we're going to try this again. Unfortunately, the first video that I recorded did not work, so this will be the second time going through this, but this is going to be the first video of notes for Unit 2. Today in 2.1, we're going to be talking about what is called simplifying radicals. So let's first talk about the three main parts of a radical. So when you talk about the nth root of a number, mainly a square root is what we'll be talking about. You're going to write it as the following expression. So you've got your square root sign, you've got your index in front, and you've got your radicand underneath. So again, where it's pointing to that letter N in front, that is what is known as the index of your radical. An index can be anything as long as it's greater than or equal to 2. So that can be a square root, a cube root, a fourth root, but we do not take the first root of a number. We don't take the 0th root. So that index has to be at least 2. The other parts, you got the actual radical sign itself. So that's kind of the official name for the square root sign is the radical sign. And then underneath is the radicand. So that is the number that you're taking the root of. Now, a lot of times we're going to see radicals that don't have an index written, so there won't be an actual number there. We're going to assume that it's being squared, so that we're taking the square root. In other words, n will be equal to 2. So when you're simplifying, here are your 3 steps to doing that. You're going to first find the largest perfect square that a radicand is divisible by, and then break your radical up into those 2 factors using that number. Step number 2, you're going to take the square root of the perfect square that will come out of the radical sign. And then step 3, we're going to leave the other factor, which is left over underneath the radical symbol, and just write it all together as one single expression. At this point, it would probably be a good idea to pause the video to copy down these perfect squares somewhere. They're going to be very important. We're going to be using them throughout the day today as we go through this lesson. Eventually, you'll probably start to remember some of the smaller ones, but some of the larger ones, like from 11 and up, you'll probably have to kind of refer to this chart to remember those. So your perfect squares, square root of 1 obviously is 1. Square root of 4 is 2 because 2 multiplied by 2 is 4. 3 multiplied by 3 is 9, so the square root of 9 is 3, and so on. So you've got 16 and 25, 36, 49, all the way up to 15 squared, so 15 multiplied by 15, which is 225. So again, I would probably pause the video, make sure you copy those down somewhere in your notes, and that way you've got them to use as we go through this video and as you work on the homework later today. Okay, now that you've got those copied down, let's go ahead and see how this works. So when you're simplifying, what we're going to do, let's start with this square root of 75. Is you're going to look for where is the smallest or the largest possible number that 75 could possibly be divided by. So what I kind of do is I look for kind of where does that happen where you start to get numbers that are less than 75. Because obviously, like the square root of 81 is 9, but 81 is more than 75. So you're not going to be able to take 75 divided by 81 and have that work. Now, that doesn't mean that 64 is going to work, but 64 is the smallest number that's less than 75. And so as you go through these, you're going to see, does 75, can you divide that by 64? And you can't. Can you take 75 and divide by 49? No. Can you take 75 and divide by 36? Nope. Can you take 75 and divide by 25? And yes, you can. 75 divided by 25 is 3. So what we're going to do then is we're going to rewrite the square root of 75 as 25 multiplied by 3. And again, you can check 25 multiplied by 3 is 75. So we're really not changing the number. We're just changing the way it looks. Now, we haven't taken a square root sign yet, so we're still going to keep the square roots above the 25 and 3. But one of those is going to simplify. We know that the square root of 25 is 5. Square root of 3, we'll leave alone. And then there is your final answer. Simplified form is 5 square root of 3. Okay. Let's take a look at another example, and I'll probably write it out one more time, and then for the rest, I will just kind of talk you through what numbers you're checking. So square root of 40, we're looking at everything kind of that 40 would possibly be able to divide by. So obviously 49 is too big, so we'll start with 36. Can you take 40 and divide by 36 to get a whole number? No. How about 25? Nope. How about 16? Nope. And so we're going to continue going to the left. 40 divided by 9. Nope. So our next one is 40 divided by 4. And yes, you can take 40 and divide by 4. 40 divided by 4 is 10. So what we're going to do is we're going to rewrite the square root of 40 as 4 and 10. And again, we'll keep square root signs above each of those since we haven't done any of that yet. Now again, we're going to simplify the one that's a perfect square. We know that the square root of 4 is 2. And so then we'll simplify that to be 2, keep the square root of 10 after it, and then there would be your answer for the square root of 40. All right, for square root of 128, we'll start with 121 and work our way to the left. 128 is not divisible by 121, not by 100, not by 81. It is divisible by 64. In fact, if you take 128 divided by 64, you get 2. So the square root of 128, you can rewrite as the square root of 64 multiplied by the square root of 2. So you're using basically these two numbers to write your square roots. Square root of 64, you already know, is 8. Square root of 2, you leave alone. And then there's your final answer. Now the nice part about square root of 100 actually ends up being that it's a perfect square. You already know square root of 100 is 10. That's all you've got to do. So when it's a perfect square, those are kind of nice. Okay. For square root of 72, let's talk about this one. So you would start at 8 and kind of work your way to the left, so starting with 64 and going down. The largest ends up being 36, but let's say, for example, you don't find 36. Let's say you maybe forget about it, and you end up thinking that the square root of 9 is the largest perfect square you can divide by. So then 72 divided by 9 is 8, so you could rewrite it as the square root of 9 and the square root of 8, where the square root of 9 is 3, and then you write the square root of 8. Now, that is actually not simplified because we didn't use the largest perfect square, but you can still get the right answer. You just have to do those steps again using the square root of 8, because you can take 8 and divide by 4, which is a perfect square right here, and that's 2. So then you would write square root of 8 as square root of 4 and square root of 2. You just have to remember to leave the 3 in front. Square root of 4 is 2, so you've got 3 multiplied by 2, multiplied by square root of 2, and then that simplifies to be 6 square root of 2, and then that's your final answer. Now, like I mentioned, square root of 9 was not the largest. So let's see how that's different from when we used the actual largest, which, as I said, was 36. So square root of 72, you could rewrite as the square root of 36 and the square root of 2, because 36 multiplied by 2 is 72. Square root of 36 is 6. Square root of 2 you leave alone, and here would be your final answer. So you can see why we want to find the largest perfect square, because that was a lot easier than the first way we worked through it. So make sure, be careful that you're finding the largest perfect square, not just any perfect square that you can divide by. Okay, let's take a look at the next one. So now we've got some numbers in front, but we're going to kind of keep everything the same. So for square root of 200, you would obviously be starting at 196 and working your way to the left. The largest perfect square you end up being able to divide by is square root of 100, which would end up being 10. So we're going to rewrite 200 as 100 multiplied by 2. So that's square root of 100 and square root of 2. And again, you'll leave the 4 in front. Now, square root of 100 we know is 10. So this is going to become 4 multiplied by 10 multiplied by square root of 2. 4 multiplied by 10 is 40. Square root of 2 you leave alone. And here's your final answer. All right. For negative 2 square root of 27, let's think about 27. So you're starting at 25 and checking numbers to the left of that to divide by. It ends up being square root of 9 that you can divide by. So that would be negative 2 multiplied by square root of 9 multiplied by square root of 3, because 9 multiplied by 3 is 27. So then let's simplify square root of 9 to be 3. So now you've got negative 2 multiplied by 3 multiplied by square root of 3. And then negative 2 multiplied by 3 is negative 6. Square root of 3 you leave alone. And here's your final answer. All right. For negative square root of 64, here's kind of what you're going to need to do for that. Square root of 64 is actually a perfect square. Square root of 64 is 8. Because there's a negative in front, that just means put a negative in front of the 8 and you're done. So when a negative is in front of a square root sign, that just means take whatever your square root was and change it to being a negative number. Okay. For the next one, for square root of 30, we would want to start by checking basically everything from 25 to the left. Notice that 30 you can't divide by 25, can't divide by 16, can't divide by 9, can't divide by 4. The only thing you can divide by is 1, but you really don't need to write that. You can just say that the answer is the square root of 30. Now, if you wanted to, it is divisible by the square root of 1. So I suppose you could write it this way. 1 multiplied by 30 is 30. And then square root of 1 is 1 multiplied by the square root of 30. But then 1 multiplied by the square root of 30 is just square root of 30. So there's really no need to do that. You can just say the answer is square root of 30 without doing any other work. Now, for square root of negative 36, you have to be careful. This is different from the one where we had the negative square root of 64. So please know that these are different. With the negative being in front of the square root sign, that is okay. What we're about to find out is that a negative under the square root sign is not okay. Because you would think that the answer was 6 because of the square root of 36 being 6. But here's what you have to be careful with. Remember, square roots are saying what number multiplied by itself is negative 36. And well, 6 multiplied by 6 is 36. So that's not going to work. You might think, well, negative 6. But if you take negative 6 multiplied by itself, you actually get a positive 36 that way as well. So then the only way it's going to work is to either take 6 multiplied by negative 6 or negative 6 multiplied by 6, but those won't even work because they're not even multiplying by the same number. It turns out that for square root of negative 36, there is no real solution or no real answer for this problem. In fact, in Algebra 2, you'll actually see that there are some other types of numbers that can help you with simplifying this. But for right now, when you have a square root of a negative number, you're just going to have to know to write that there is no real answer. All right, that's all I've got for us today. If you have any questions, be sure and let me know. On our next video, we'll talk about how to multiply and divide radicals and use some of the ideas of simplifying that we talked about today. Until then, have a good rest of your day.